NASA's $10 billion James Webb Space Telescope, JWST, has literally been created to take a voyage back to the birth of the universe. And now, after being in space for a little more than a year, the stunning results it's already returned are proving it's worth every penny. For proof, just take a peek at the awe-inspiring images captured by James Webb. Images like this not only make for perfect desktop backgrounds, but they also hold great scientific value. Join us as we dig into the James Webb Telescope's first ever real images before the Big Bang. Looking back in time might sound like a strange concept, but it's what space researchers do every single day. Our universe is bound by the rules of physics, with one of the best-known rules being the speed of light. And when we talk about light, we're actually referring to all the wavelengths across the electromagnetic spectrum, which travel at around a whopping 300,000 kilometers per second. Light travels so fast that in our everyday lives, it appears to be instantaneous. Even at these breakneck speeds, it still takes some time to travel anywhere across the cosmos. When you look at the moon, you actually see it as it was 1.3 seconds ago. It's only a tiny peek back in time, but it's still the past. It's the same with sunlight, except the photons, light particles, emitted from the sun's surface travel just over 8 minutes before they finally reach Earth. Our galaxy, the Milky Way, spans over 100,000 light-years, and the beautiful newborn stars seen in JWST's Carina Nebula image are 7,500 light-years away. In other words, this nebula as pictured is from a time roughly 2,000 years earlier than when the first ever writing is thought to have been invented in ancient Mesopotamia. Anytime we look away from the Earth, we're looking back in time to how things once were. This is a superpower for astronomers because we can use light as observed throughout time to try to puzzle together the mystery of our universe. Space-based telescopes let us see certain ranges of light that are unable to pass through Earth's dense atmosphere. The Hubble Space Telescope was designed and optimized to use both ultraviolet, UV, and visible parts of the electromagnetic spectrum. The JWST was designed to use a broad range of infrared light, and this is a key reason the JWST can see further back in time than Hubble. Galaxies emit a range of wavelengths on the electromagnetic spectrum, from gamma rays to radio waves and everything in between. All of these give us important information about the different physics occurring in a galaxy. When galaxies are near us, their light hasn't changed that much since being emitted, and we can probe a vast range of these wavelengths to understand what's happening inside them. But when galaxies are extremely far away, we no longer have that luxury. The light from the most distant galaxies, as we see it now, has been stretched to longer and redder wavelengths due to the expansion of the universe. This means some of the light that would have been visible to our eyes when it was first emitted has since lost energy as the universe expanded. It's now in a completely different region of the electromagnetic spectrum. This is a phenomenon called cosmological redshift, and this is where the JWST really shines. The broad range of infrared wavelengths detectable by JWST allows it to see galaxies Hubble never could. Combine this capability with the JWST's enormous mirror and superb pixel resolution, and you have the most powerful time machine in the known universe. Using the JWST, we will be able to capture extremely distant galaxies as they were only 100 million years after the Big Bang, which happened around 13.8 billion years ago. So, we will be able to see light from 13.7 billion years ago. What's about to hurt your brain, however, is that those galaxies are not 13.7 billion light-years away. The actual distance to those galaxies today would be roughly 46 billion light-years. This discrepancy is all thanks to the expanding universe and makes working on a very large scale tricky. The universe is expanding due to something called dark energy. Dark energy is thought to be a universal constant acting equally in all areas of spacetime, the fabric of our universe. And the more the universe expands, the greater the effect dark energy has on its expansion. This is why even though the universe is 13.8 billion years old, it's actually about 93 billion light-years across. Working like a time machine, the first images shared by this powerful telescope on July 12 showed us far-off galaxies, the death of stars, and the atmosphere of planets outside our solar system. Now, over a year after it was launched, James Webb has gifted scientists and all humankind with new breathtaking images from space, this time offering us insight into how stars are born. This is Cassiopeia A, a supernova remnant located 11,000 light-years away that spans 10 light-years across. The Webb image contains all the chaos and beauty you would expect from the remnants of an exploded star, including cosmic material glowing orange and red due to emission from warm dust. In these areas, material ejected by the exploded star has smashed into the surrounding material. The knotted filaments that appear pink in the image are material from the star itself, shining due to the presence of heavy elements and dust emission. This image of Uranus was captured by the James Webb Space Telescope on the 6th of February 2023 and shows an amazing view of the planet's ring. The bright region on the right side of the planet is Uranus's polar cap, which is unique to Uranus because it is the only planet in the solar system that's tilted on its side, causing extreme seasonal changes. The latest deep field image captured by the James Webb Space Telescope shows a region in deep space known as Pandora's cluster or Abell 2744. It reveals the intricate structures of 3 galaxy clusters together forming a so-called mega-cluster in detail never seen before by astronomers. The image of Pandora's cluster is a panoramic composed of 4 individual JWST images sewn together. One noteworthy feature of the image is that it displays gravitational lensing, where the mass of the galaxy clusters is warping and distorting the light from more distant galaxies. In this way, the galaxy megacluster is acting like a cosmic magnifying glass, enabling astronomers to see the distant galaxies more clearly. This image captured by the James Webb Space Telescope shows thousands of distinct galaxies and covers an area of the sky just 2% of the area covered by the full moon. The faintest objects in the image are about 1 billion times fainter than what can be seen with the naked eye. This is referred to as a medium deep wide field image. Light from the most distant galaxies has traveled almost 13.5 billion years to reach us. JWST's latest image is of a protostar embedded within an hourglass-shaped cosmic cloud. The star is just 100,000 years old and thought to be in the earliest stages of star formation. Once hidden from sight within dark cloud L1527, the features of this protostar are now revealed by Webb's near-infrared camera, NIRCam. The protostar is still a long way from becoming a fully-fledged star, and as a result, it is not yet undergoing nuclear fusion of hydrogen. This disk, seen as a gray streak at the center of the image, is about the size of our own solar system. Perhaps Webb has offered us a glimpse of what our own sun must have looked like in its infancy. Amazingly, JWST also spotted galaxies from the first 350 million years after the Big Bang. That makes these the earliest galaxies ever observed, and they had some surprises in store, such as being far brighter than expected. That means there's more for us to learn about how galaxies form in the early universe. These early galaxies are identified using surveys in deep field images, which use Webb to look at large patches of the sky, which might look empty at first glance. These areas don't have bright objects like solar system planets and are located away from the center of our galaxy, allowing astronomers to look out into the depths of space to spot these extremely far-off objects. JWST was able to detect carbon dioxide in the atmosphere of an exoplanet for the first time and recently discovered a host of other compounds in the atmosphere of planet WASP 39b as well, including water vapor and sulfur dioxide. That not only means that scientists can see the composition of the planet's atmosphere, but they can also see how the atmosphere is interacting with light from the planet's host star, as sulfur dioxide is created by chemical reactions with light. Learning about exoplanet atmospheres is crucial if we ever want to find Earth-like planets and search for life. Previous generation tools can identify exoplanets and determine basic information like their mass or diameter and how far they orbit from their star. But to understand what it would be like to be on one of these planets, we need to know about their atmospheres. With data from JWST, astronomers will be able to look for habitable planets far beyond our solar system. It's not only distant planets that have been getting JWST's attention. Closer to home, JWST has been used to study planets in our solar system, including Neptune and Jupiter, and will soon be used to study Uranus as well by looking at the infrared range. JWST was able to pick out features like Jupiter's auroras and a clear view of its Great Red Spot, and the telescope's high accuracy meant it could view small objects even against the brightness of the planets, such as showing Jupiter's rarely seen rings. It also took the clearest image of Neptune's rings in more than 30 years. Another major investigation JWST performed this year was of Mars. Mars is the best-studied planet outside Earth, having played host to numerous rovers, orbiters, and landers over the years. That means astronomers have a fairly good understanding of its atmospheric composition and are beginning to learn about its weather system. Mars is also particularly difficult for a sensitive space-based telescope like JWST to study because it is so bright and so close. But those factors made it the perfect testing ground to see what the new telescope was capable of. JWST used both its cameras and its spectrographs to study Mars, showing the composition of its atmosphere, which matched up almost perfectly with the expected model from current data, showing how accurate JWST's instruments are for this kind of investigation. Another aim of JWST is to learn about the life cycle of stars, which astronomers currently understand in broad strokes. They know clouds of dust and gas form knots that gather more material to them and collapse to form protostars, for example. But exactly how that happens needs more research. They are also learning about the regions where stars form and why stars tend to form in groups. JWST is particularly useful for studying this topic, as its infrared instruments allow it to look through clouds of dust to see inside regions where stars are forming. Recent images are showing the development of protostars and the clouds they throw off and are looking into the regions of intense star formation such as the famous pillars of creation in the Eagle Nebula. By imaging these structures in different wavelengths, JWST instruments can see different features of dust and star formation. Speaking of the pillars of creation, one of JWST's biggest legacies in the mind of the public is the stunning images of space it has captured. From the international excitement at the reveal of the telescope's first images in July to new views of iconic sites like the pillars, Webb images have been everywhere this year. As well as the gorgeous Carina Nebula and first deep field, other images worth taking a minute to wonder over include the star-sculpted shapes of the Tarantula Nebula, the dusty tree rings of binary star Wolf-Rayet 140, and the otherworldly glow of Jupiter in the infrared, and so on. In short, we live in a remarkable time of technology. Just 100 years ago, we didn't know there were galaxies outside our own. Now, we estimate there are trillions, and we are spoiled for choice. For the foreseeable future, the JWST will be taking us on a journey through space and time each and every week. You can stay up to date with the latest news as NASA releases it. Then let's sit back and enjoy. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. And as always, thanks for watching, and we will see you next time.